Hello everyone, this is Sachin, PhD student from Material Science and Engineering, IIT Kanpur, working under the supervision of Dr. Kaustubh Kulkarni. My research topic is diffusion in nickel-based superalloy. Okay, we will move on into the till now we have taken the till now we have seen the phase diagram of iron carbide. So what are the microstructure development? Microstructure development and a small part of problems in the previous videos. So we have seen only the introduction part. So what is the methodology that we had used to solve the problems in this one? Today in this lecture videos, we are saying about the problem based on tie line and liver. Okay, so these are the main two concepts that we will use to solve and know, and we will know the composition and a weight fraction in a phase, right? Weight fraction of elements in a given phase, and we will solve some few problems like 3 to 4 problems in this video lecture. Okay, let's start with the introduction. That introduction is about liver as well as tie line is. So before that one, I will draw the small portion of an iron carbide diagram. Okay, so if you are considering the line with the alloy with the composition of X weight percent of carbon, then we can know the weight fraction as well as the composition. The composition can be known by drawing a tie line. So if you consider this is A, this is B, and this is C, then the composition can be composition of alpha farad is given by BC divided by AC. So composition of Fe3C total ferrite, so total cementite can be determined by help of AB divided by AC. These are the basic equations that here we will write, instead of composition we will write it as instead of composition here it is weight fraction. Sorry for inconvenience. Please note on, this is not a composition, this is a weight fraction. Okay, so composition, this is a liver root, right? So next is composition. That is only by drawing a straight line in the on this one. So this is the composition of alpha ferrite and this is the composition of cementite. In a this alloy. Okay, this is a basic equation. Okay, let's start. First problem: compute the mass fraction of ferrite, alpha ferrite, and the cementite in a perlite. Before that one, we will draw. Sorry, this is not straight line. Compute the perlite, right? If mass fraction is asking about weight fraction, right? Mass fraction is nothing but weight fraction only. Weight. Yes. Yeah. Now we have this small portion of iron carbon phase diagram. This is alpha, this is gamma, and we need to compute the mass fraction of the ferrite as well as the cement. So if you want to know the mass fraction, then we have to use a first is a lever rule, right? So from the lever rule, at this temperature T, we can get the mass fraction of alpha as well as cementite, alpha ferrite as well as cementite. First, we will know the alpha ferrite as this difference, this minus this divided by whole length of this, right? 6.70 minus 0.76. That means whole length of a line is 6.70 minus 0.022. This will comes to the value of 0.8894 into 100. That is 88.94 weight% of alpha and second is cementite. That is given as 0.76 minus 0.022 divided by this is 6.70 minus 0.022. This will rises to the 11.05 weight percent, right? So as we discussed from the previous video lecture, that is consist clear that alpha ferrite is having a maximum portion when compared to that of the cementite. That is 88 point, nearly 88%. This is all about 82%, 89%. This is 11%. Okay. Now in this problem, let's start with it. Compute the mass fraction of a prototype ferrite and a perlite that from iron carbon alloy containing 0.30 0.35 weight% of a carbon. Okay, we will draw an iron carbon diagram. So if you want to solve any problems in a phase diagram, we have to draw a phase diagram, portion of a phase diagram. So from the given data, we need to calculate the weight fraction of prototype ferrite as well as the perlite from this one. So in this one, a new concept is about the weight fraction of the proeutectoid ferrite. Because it's a hypoeutectoid, there is a formation of a proeutectoid within the microstructures. So we need to find the weight fraction. First task is weight fraction of proeutectoid. I will symbolize into the alpha prime. So proeutectoid ferrite. That can be calculated by drawing the same lever rule. In this one, we need to find the protractor. This is a protractor. We have to consider only within this to find the weight fraction of protractor. We have to consider from here to here. That means 0.76 minus 0.35 divided by 0.76 minus 0.022 is a weight fraction. From here, we will get it as 55% weight percent of protractor current. So second one is weight fraction of perlite. So weight fraction of the perlite can be determined by the opposite thing. That is 0.35 minus 0.022 divided by 0.76 divided by 0.022. This is a weight fraction. From here we will get it as perlite weight fraction as 44. This is the weight fraction. This problem I have taken because of this proeutectoid ferrite. So most of the gate papers they will ask this more weight fraction of proeutectoid. So same thing we can apply for the cementite also. In this one, in detail, in depth, we can calculate the total amount of the ferrite, alpha ferrite, and total amount of the cementite by considering the whole length from here to here. Whole length, that is alpha total ferrite, alpha ferrite can be calculated this 6.67 minus 0.35 divided by 6.67 minus 0.022. This is the total amount of the ferrite present in this microstructure, and as similarly Fe3C, that is the cementate, can be calculated by considering 0.35 minus 0.022 divided by whole length, that is 6.67 minus 0.022. So I have given you a equation formula, then just calculate and please mention in the comment box answers for these things. Okay, yeah. We are jumping into the next problem, that is the microstructure of an iron carbon alloy consisting of proteictoid, ferrite and the perlite. The mass fraction of these two microconstituents are 0.174 and 0.826 respectively. Determine the concentrations of the carbon in this alloy. So in this one, he has given need to find the composition of this alloy, carbon composition. This is we don't know. That is considered as X value, Cx value, and we know the weight fraction of proteictoid ferrite, that is alpha prime, that is 0.174, and weight fraction of perlite, that is 8 to 6, right? First of all, we will take a we will draw a lever rule, weight fraction of alpha, that is A, B, C. We need to consider only the ferrite as well as perlite. So that's why I'm considering this length, right? Okay. So alpha ferrite is given as BC divided by AC. That means we don't know the value of this distance BC, CX minus, sorry. So this will value will be the lesser value. So I have to consider. Okay. This is C at C. This will be 6 point, oh, sorry, point 0, 0.76, 0.76. That is 0.76 minus x value divided by whole distance. We know this value, right? 0.022. 0.76 minus 0.022. We know this value and we need to calculate the x value. This is very easy, right? First standard mathematics, x and 0.022, right? This is from here we will get the x value. The x value is approximately 0.63, just very near to, here it is probably very near to perlitic structure, eutectoid alloy 6, right? This is the value of the carbon that is present near the this one. Our next problem is about compute the mass fraction of pro-eutectoid cementite in an iron carbon alloy containing 1 weight percent of carbon. This 1 weight percent from the phase diagram, it is clearly indicates that it comes under the hypereutectoid steel. So we need to, there is a term called as proeutectoid cementite will exist in this composition of carbon, right? So we need to find the weight fraction of this eutectoid cementite first of all. And for additional, we can also calculate the weight fraction of the perlite that is formed. From the microstructure, it is clear that, so, example, this is a microstructure, this is a perlite, and nearby here we will get a proeutectoid cementite. This is a perlite, right? This is a perlite and this is a proeutectoid cementite. So we need to calculate this one as weight fraction of this one and weight fraction of this one, right? So first of all, we are calculating weight fraction of proeutectoid cement, right? First, weight fraction of Fe3C dash, that is given as AB divided by AC. That means 1% minus 0.76 divided by 6.70 minus 7.76. So this comes into, so finally this will comes as answer as 4.04. Then the weight fraction of the perlite can be calculated by BC divided by AC. that is given as 6.70 minus 1 divided by 6.70 minus 0.76. For this one, we need to calculate within this area only, right? He is asking protected cemented as well as he is not asked for the second thing. I am calculating my own. So this will comes into 95.59. In simple, we can also calculate this is 1 minus of this weight fraction of protected cementite, that is 4.40. This will also give resistance to, so 95.95, because if you remove this protected cement, only the remaining is perlite. That's why we are subtracting this in 100. Consider this is 100. Okay, right? So I will give a small task, that is need to calculate. So I will take a new one. So assignment is need to calculate total weight percent of alpha ferrite, and second task is calculate total weight percent of cementite. You have to change the length of lever rule. This is a small hint for calculating these two problems, right? This can be calculated. Take the data from the previous last example, that is 1 weight percent of carbon, right? So this is a assignment task. Please do it and place the answer in the comment box sections. Otherwise, I will explain this task in the upcoming video. Okay? Yeah. Thank you. Thank you. So next video lecture, I'm planning to go into the kinetics of phase transformation, nucleation, growth, etc. These is some next topics are very important topics. Growth phenomena, how this microstructure have been evolved, starting and the growth. We are seeing by undercooling, how this undercooling will affect these two properties. Okay, how this evolve into microstructure, final microstructure. We'll get into this one.